What? No, that would be cheating. What, Emma? Okay. All right. So the last chapter, I don't even remember, but I'm guessing there was some trig in there that we were doing. We were doing trig stuff. Is that what it was? It was completely trig. Okay. All right. So now we're going to do some things with the completely trig that you guys learned. You don't have to. How's that? Is that better? Artsy. All right, so the first two sections in this chapter you are going to absolutely love. What the first two sections are about is starting with some trig stuff written one way and then using these trig identities up here to switch it around and have it be some trig stuff written in a different way. Okay? And if you don't believe me that you're going to love this, you should talk to if you know anybody in my sixth period class, because we just now are finishing this in that class, and they're like, oh my gosh, this is the best thing I've ever done in a math class in my life. Okay? Oh, and then these two sections are a little bit weird. We're going to skate through those pretty quickly, but then these last two sections are money. This is how you can use trig stuff in triangles that are not right triangles, making them uber useful. Okay? Uber like the car, Uber like the German word which means beyond. So chapter 5 overview, nobody cares. All right, so here are some basic trig identities. These are all written on the wall up here, thanks to Elena Diaz. You can obviously copy them down into your notes if you want to have them closer at hand, or if you want them for homework or whatever. But we've talked about these before. Cosecant and sine are inverses of each other. Secant and cosine are inverses of each other. And cotangent and tangent are, I shouldn't say inverses, are reciprocals of each other. And then the same thing is true, you can go the opposite way. So these two are basically the same, just written in the other direction. Grace, can I get you to, yeah, thank you. Okay, and then I don't remember if we talked about these before or not. Tangent is also, you can write that as sine over cosine, which means that cotangent, you can take that and flip it over and write it as cosine over sine. You guys want a second to copy those down? Those of you who want to? Okay, tell me. All right. This is the meat and potatoes of these two sections that we're going to do these first two in the chapter, okay? This first one is, if you're going to go see just one movie this summer, that's the one you should go see, okay? Cosine squared plus sine squared equals 1. That is the most important of all of these things, okay? If you just remember one thing from this section and the one after it, cosine squared plus sine squared equals 1, that's the one that we would like you to remember, okay? These other two just come from this one, okay? So the way the next one you get it is if you take all three of those things and divide them by cosine squared, then cosine squared divided by cosine squared is 1. We just saw on the previous slide that sine over cosine is equal to tangent, so that means sine squared divided by cosine squared is tangent squared. And then we also saw in the previous slide that 1 over cosine is secant, so that means 1 over cosine squared is secant squared. So you can take this one and you can get this identity, or you can take this one and instead of dividing by cosine squared, if you divide by sine squared, then you get this thing for free, because cosine divided by sine is cotangent, so cosine squared divided by sine squared is cotangent squared. Sine squared over sine squared cancels and gives you 1, and 1 over sine squared is cosecant squared, okay? So if you just remember sine squared plus cosine squared equals 1, then you get the other two for free, okay? Right, yes. Can you get what? Uh-huh. And the reason why that's called the Pythagorean identity is because cosine goes with the x, sine goes with the y. So this is really just saying x squared plus y squared is equal to the radius squared, which is just going to be 1. All right? Okay, so let's figure this one out. Let's find the sine and the cosine if we know that the tangent is equal to 5 and we know that the cosine is positive. Okay? So what is another way that I could write tangent? I could go 1 over cotangent, but I want to figure out sine and cosine, so hang on. All right. On this one right here, it says 1 plus tangent squared equals secant squared, right? Whatever. Okay, so if tangent is 5, then I can rewrite this as 1 plus 5 squared equals secant squared, right? And so that means secant squared equals 26, correct? Right? Which means that secant equals plus or minus the square root of 26. 25 plus 1. Okay? Are you guys with me so far? Because anytime you're solving an equation and you take a square root, you want both the positive and the negative square root, okay? Okay, but secant is 1 over cosine, right? So that means that cosine is 1 over plus or minus the square root of 26. But then we're told right here that cosine is positive, so that means we're going to throw out the negative and say that cosine is 1 over the square root of 26. Does that make sense? Okay. Then where I thought we were going, Braden said that tangent is equal to sine over cosine. So if this thing equals 5, hang on just a second, then that means that sine has to be 5 times bigger than cosine, right? So that means if cosine is 1 over the square root of 26, what is sine? 5 over the square root of 26. Okay? Carter? Yeah. The other probably easier way that we could have done this, that we've done this before, is if you know that the tangent of an angle is equal to 5, you can just draw a little triangle. Opposite is 5, adjacent is 1. 5 squared is 25, 1 squared is 1, so that means this is the square root of 26, right? And then cosine is adjacent over hypotenuse, 1 over square root of 26. Sine is opposite over hypotenuse, 5 over the square root of 26. So that's the way that we would have gotten this before, by drawing a triangle. But this is maybe, I don't know, you don't have to draw any triangles. Maybe you don't like doing that. Okay? I don't know. Why is this one 5 over square root of 26? Because the tangent is sine over cosine, and if the tangent is equal to 5, that means that this has to be 5 times bigger than that for those two things, okay? And so I just took this and times it by 5, okay? Okay, that was kind of a weird one. I don't feel like we want to know those, so we might come back to those. Maybe we won't. Okay, this is the fun stuff. This is the stuff that you guys are going to be excited about. Let's take sine cubed plus sine x cosine squared x, and let's simplify that. All right? This is the good stuff. Yeah. Anything jump into your head? X? Okay, I can't factor out an x because the x's are locked up in the sines and the cosines, bless you. But I can factor out a sine of x because they both have a sine of x. So I'm going to factor sine of x out of both of these things. If I factor sine of x out of sine cubed x, what am I left with? Sine squared x. If I factor sine x out of sine x cosine squared x, what am I left with? Well, I factored out the sine, though, so then I'm just left with cosine squared of x. And what does sine squared plus cosine squared equal? 1. Remember that. Sine squared plus cosine squared equals 1. So this becomes sine of x times 1, which is just plain old sine of x. Okay? So it turns out that this funky, crazy thing, sine cubed plus sine x cosine squared x, is really the same as just sine. Because sine squared plus cosine squared equals 1. No, be this guy. Yeah, absolutely. And I hate to be this guy, but let's remember the title of the book is Pre-Calculus. And so sometimes when we're doing a calculus problem, we'll be asked to maybe take the derivative of this or the integral of this. We don't know how to do that. So we have to simplify it down to something we can do more easily instead. Okay? Then one might wonder why you are in a pre-calculus class. Oh, okay. Well, if you are just the kind of guy that someone just tells you to do this and then you just do it, I'm just telling you to do that. Just keep doing that then, Will, all right? Keep living your life that way. What's that? I want you to take stats next year too, yeah. Okay, because right? Right? The triangle that we've been working with, okay? What is the sine of theta? Okay. What is the cosine of theta? X over r, right? Okay. What is the sine squared of theta? What is the cosine squared of theta? If you add these together, over here you get sine squared plus cosine squared, right? And over here I get x squared over r squared plus y squared over r squared, right? But by the Pythagorean theorem, and this is why it's called the Pythagorean identity, on this triangle, x squared plus y squared equals r squared, right? So that means that if I take this, and since they have a common denominator, if I write it as a single fraction, x squared plus y squared over r squared, I know x squared plus y squared equals r squared, so that equals r squared over r squared, which equals 1. Okay? So that's how that works. That's how that, where that comes from. Nice job. Okay? What? Mind blown. All right, let's simplify another expression. Indigo, you ready? Are you playing a game? Are you texting a friend? Looking at Instagram? Just whatever. It's just not this. Anything but this, Mr. Aldrich. This is so boring. I'd rather look at pictures of cats in swimming pools. All right, so let's simplify secant x plus 1 times secant x minus 1 over sine squared. See what we can get going with that. Thomas, how about you? What do you got going there? Okay. What does your math impulse want you to do with this problem? Right. You really want to FOIL this out, right, and get rid of the parentheses. Isn't that the first thing that it like screams out to you when you see this problem? Okay, so secant times secant is secant squared. This is, after all, an air quotes honors pre-calculus class, so I'm going to assume that I don't have to do the inside and outside ones because you guys know those will just cancel. I'll have a secant x and I'll have a negative secant x. And then plus 1 times minus 1 is minus 1. And that is still over sine squared. Okay? All right, secant squared x and a 1. Seems like somewhere we saw those before. I can't remember where. Earlier this day. Like 7, 8 slides ago. What is the Pythagorean relationship that involves secant squared and 1? Does anyone have that? Okay, 1 plus tangent squared equals secant squared. Okay, so do you guys see that if 1 plus tangent squared equals secant squared, I can subtract 1 from both sides, and then also show that tangent squared equals secant squared minus 1. Right? For sure, yeah. Yeah, just like, you know, I don't know what to do. I'm going to just go over to this cupboard over here, just pull some random thing out, throw it up on the board, and then it works. Yeah. But you guys know in your hearts that that's not true, because whenever one of you, like Glory just did, says, why is that true, I can take it into fundamental level and show it to you. What you're saying is you wouldn't be able to figure out to do that on your own. Yeah, I understand that. Like when you're solving an equation, there's some set rules that you go through step by step to get to the answer. This is a little bit more difficult. This is just like sort of free form, just figure it out. And that's why you're going to love this so much, is because it allows you to be creative with your math. No, because we can simplify this too. What is tangent? Tangent is sine over cosine. Okay? So I'm going to take tangent and I'm going to rewrite it as sine over cosine. And then just for funnies, I'm going to rewrite sine as sine over 1. And I'm going to say, Emma Jensen, you are on your phone too much, young lady. No. Yes. Yeah, just getting cocky. You looked at you were like, 95% on my midterm. I totally got this. No. I can slack off like Indigo and Grace and Tristan and still be fine. Yes, ma'am. Well, you know that tangent is sine over cosine, right? So that means tangent squared is sine squared over cosine squared. Okay? Okay, what do I do when I'm dividing two fractions? Multiply by the reciprocal. So now I'm going to go sine squared of x over cosine squared of x times 1 over sine squared of x. What the sine squareds cancel. So that leaves me 1 over cosine squared of x. But 1 over cosine is the same as secant. So 1 over cosine squared is secant squared. Oh yeah, this is money. Right, no, it's from that chart up there. Maybe I need to have someone else make one with all these things on there. You don't need extra credit, kid. Oh, well, anything is just over 1, right? So I just took this and I just made it over 1. Yeah, okay. I will give extra credit to the first student who brings a poster with those 3 Pythagorean identities on there. The sine squared plus cosine squared and the tangent and the... I don't want that. I just want a poster with the 3 Pythagorean identities. Okay. That might be too late. Okay, let me give you guys some easy ones to work on, and then we'll continue.